Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, let us try to understand what is the concept of producer key and message acknowledgement in Kafka. Okay. So in my previous video, I started discussion on Kafka from scratch. That is how to install Kafka in our local system, to how to integrate Kafka with Python, and lot of other concepts related to Kafka architecture we have covered, right? So if you want to know those detailed explanations, you can go through the link given in the description box, because those videos will surely help you to understand this particular concept what I'm going to cover in a better way. Okay, so that's why if you are not aware of those concepts, just have a look in the description box. Okay, so without any further delay, let's start with our first topic, that is Kafka producer. Okay, so as we have already discussed in our previous video, that in Kafka cluster, a topic can have multiple partitions, right? Now, when a producer is publishing message in a particular topic, how the message will be distributed? How the Kafka cluster will put some message in a first partition, how it will put some message in a second partition, like that, how it will happen? Let us try to understand that. Okay, that's what is the question. How does a producer know how to send the data to a topic partition? That is, in which partition the data will be written, how it is working in the backend. So for that, we use the concept of message keys. Okay, so what is that? That is, alongside the message value, we can choose to send a particular message key, and that can be whatever you want. It can be a string, it can be a number, whatever. And if you don't send any key with your actual value, then the key is set to null. Okay, then what happens? Kafka will apply some hashing algorithm like this way. Suppose this is our hashing function, and here we are passing our key with our message. So key will be input for a hashing function, and that hashing function will give a certain output. Okay, and a particular output will always be mapped to a particular partition out of multiple partitions in our Kafka. Okay, so like just consider one example. Suppose the hashing concept is I will divide by 3, and whatever remainder I will be getting, based on that I will be putting that in different partition. Okay, so like for example, suppose my key is 7. Okay, so if we do this operation, then the remainder will be 1, right? So what Kafka can decide, maybe we are having 0, 1 and 2, 3 partitions are there. So Kafka will put this particular message with the key 7 to the partition 1. Okay, right, here it will be coming because the remainder is 1. Suppose the key is 5. So if we do this particular operation, then the outcome will be basically 2. Okay, so if some message is having the key 5, then after applying hashing algorithm we are getting 2. So Kafka will send to partition number 2 that message. Okay, like that it will be distributing. Simple how generally partitioning works in big data world, like that same kind of concept. Okay, so if the key is set to null, what Kafka does? Kafka basically follows round robin fashion. So suppose key is null, we are not passing the key, then what Kafka will do? Suppose we are having the partition 0, 1 and 2. So the first message the Kafka will put in partition 0, the second message it will put in partition 1, the next message it will put in partition 2, and then again it will put the fourth message in partition 0, then next one partition 1, like that round kind of circle it will be keep on doing. That's what the round robin algorithm, right? So that's what is written here. So that means if you don't specify any key, if the key is null, then it will be following round robin fashion. That means your first message is going to be sent to partition 0, your second message is going to be sent to partition 1, next one is going to be sent to partition 2, and so on. Okay, again it will repeat to partition 0 and make a full cycle like that way. Okay, so this is why it is called round robin. And if you are putting the key, then it will apply the hashing algorithm, and based on the outcome of the hashing value it will send to a particular partition. Okay, and here another important point, that in case of you send the key with your message, obviously you can understand that all the messages that share the same key will always go to the same partition. Okay, so suppose I am sending multiple messages. Okay, and suppose for all the messages I am sending a common key 7. Now suppose my hashing algorithm is the same one what I discussed, that is, first I will divide by 3, and whatever remainder I will be using that to decide to which partition the data will be going. So if we are passing same key, then after applying hashing value we will be always getting constant output. Like here also I will be getting 1, Here in this case also I will be getting 1, in this case also I will be getting 1. So all this message with same key after applying hashing algorithm will be getting same value. So that way it will be always going to partition 1. Okay, like that. Just for example I am telling. So in general you can remember like this way, that if you are sending the key with your message, then all the message that share the same key will always go to same partition. Okay, very important point, and I hope if you have working experience in big data world, this is not a very new fact to you, because this is how it works in partitioning domain, right? I hope you understood the overall concept of message keys. So just you can remember, based on keys the messages are distributed among different partition in a Kafka topic. Okay, so another important point here it is written, we have to keep in mind while doing the lab, that is to enable sending the full key value pair. Okay, so earlier we were sending only value whenever we did experiment, but now if I want to show you the partitioning concept, how the message is distributed, so I have to send key value pair, right? So if I want to do that way using command line, then we have to make sure we are passing these two while starting the producer. One is parse key. What is parse key? Default value is false. If it's true, then the message key is mandatory. That means if we are keeping this parse key true for our producer, then the producer must has to send the key along with value. So if we want to do some exploration with key value concept and the data distribution based on key, we have to keep the parse key as true. Another important point is key separator. Okay, so we are going to send key value pair. So value part is our actual message and key is how the message will be distributed across partition, right? So what is the separator in between key and value? That also we might need to mention. Like we will be showing you the demo with colon separated. Okay, key and value can be separated with colon. So I will show you the lab section, then you will be getting better idea about these two important properties, what we need to configure. Okay, so without any further delay, let's switch to the lab section, right? So here I will go to my notepad, and here what I will do as a first step, I will start my Zookeeper. Okay, so here I have cleared all the logs. So if you see Zookeeper logs, nothing is there. Server logs also nothing is there. And I will start my fresh cluster. First with Zookeeper, I will run the script. I will go to terminal and I will paste and I will run Zookeeper. This is same how we did earlier. Here you can see it is running in port 2181. That's fine. And then here we are starting our Kafka server. Okay. So here I started Kafka server. By default it will run in port 9092. Okay, here you can see the broker is running at port 9092, and here also one more thing, that Kafka broker ID is 0. That's how the server properties is configured, right? Now in another terminal, what I will do, I will create a topic. Okay, so for this demo I am keeping partitioning to replication factor 1 I am keeping, because I am not launching a multi-node cluster, but the same concept will be applied in multi-node cluster as well. Okay, so I'll just paste this and I will hit an enter. So here you can see I am creating a topic with hello world 2. Okay, so here I will start my producer. So point to be noted, earlier in our previous videos, whenever we started producer in our console, then we use this kind of code. But this time we need to add two more extra properties, that is parse key true, because we want to send the key, and property is key separated is colon, that is key value will be separated by colon. Okay, so this is how you have to start the producer. And I will hit an enter. The topic name I am keeping hello world 2 only, and here you can see the cursor is blinking after the angle bracket, that means producer is started. All we can do, we can start the consumer in another site. Okay, so I will just minimize my Python console little bit, and here I will open a command prompt and I will start my console. Okay, right? So let's start producing messages. So here you can see I have written some messages. I will publish them. But before that, let me just show you how the logs are getting changed. I can go to server log, and here you can see for my this particular topic, two partitions are created. So topic name is same hello world 2, but the partition one is 0, another one is 1. Okay, like that. So let's publish some messages. So 1001. So here this is basically acting like key and this is acting like value, because I have configured key separated is colon. So based on colon, Kafka will understand, okay, after colon whatever is there, that is value. And we can pass multiple value. I am basically passing the value like a CSV file, that is comma separated values. Okay, and the 1001, 1002, these are basically key. Okay, So on top of this, hashing will be applied, and based on this our data will be distributed. Okay, so here I can paste my first key value pair, that is here, and here you can see in consumer also only the value part is coming, that is mobile 100. Okay, then here I can publish another key value pair, so new key 1002 we are passing, so I can pass and hit and enter, and here you can see that same message has came, only the value part. Then like that way I will publish another key value pair, but now I am repeating the key. So 1001 earlier also I passed, now also I am passing 1001. Okay, I will hit and enter, and here you can see the same value part is coming. Okay, then next one I am passing a new key 1003, and here I will hit and enter, and another one 1002. Okay, I'll paste and I will hit and enter. Okay, so like that way 5 messages I published. In consumer side 5 messages are consumed. Okay, from the value part there is no change, whatever producer published the value, that value only consumer has consumed. Okay, now let's see how the data is stored in the partition in our Kafka topics. Okay, so here what I will do, I will go to server logs, and obviously our messages are distributed among these two partitions. So let's go to the first partition for our topic, and if I open this one, here you can see the messages related to key 1001 are stored here. Okay, so if you observe carefully here, out of these messages we are having 2 message or 2 key value paired with key 1001. Okay, so here you can see 1001 came here, and message which is having key 1001 that came here. Okay, so that means you can understand one thing, that key value pair with same key are coming in one single partition only. Okay, that is all the keys which are having 1001, they are coming in this partition. Okay, partition 0. Now let's go to our partition 1. If I open, here you will see that the 1002 key and 1003 key are coming here. Okay, so if you see here 1002 key came. Okay, so maybe the hashing algorithm whatever applied in the back end, after applying the hashing on 1002 and 1003 both the key, we are getting same output. That's why for both the keys we are getting the data in same partition. That's fine, but one thing should be clear, that always now moving ahead, if I am publishing some message with key 1002 or 1003, all the messages should be coming in this partition 1 only. If I am publishing some message with key 1001, then it should go to partition 0 only. It should not be shuffled. Okay, that's what I tried to highlight here. That is, all messages that share the same key will always go to same partition. So let's see that. Okay, so I can pass one message 1001, and here I can like notebook comma 99. Okay, so 1001 key is going where? It is going to partition 0. Okay, so this message also should go to partition 0. Okay, so let's see. I will hit and enter, and here you can see in consumer as it is coming, but because that key is 1001, so it should obviously go to partition 0. Okay, because that's how 1001 was going in our first check, right? So here you can see older messages are there, and along with that, if I scroll right, here you will see that the key and value pair is added. Okay, so 1001, if that is the key, then always it is coming at partition 0. Okay, I can show you another message, maybe 1003. Okay, and here I can put class comma 50. Suppose this message I am passing, and currently I pass the key 1003. So 1003 we have seen it is going to partition 1. So we should see that new message also in partition 1 only in append manner. Okay, if I scroll right, here you will see 1003 class 50 is coming. That means one simple conclusion is all the messages that share the same key will always go to same partition, and it might happen that different keys are also going to same partition. Like here we have seen 1002 and 1003 are going to same partition only. That is fine, because it might happen that in the backend, after applying the hashing algorithm on the key 1002 as well as 1003, the outcome is coming as same. That's fine. But one thing for sure clear, that 1002 related messages will always go to one single partition only. It will not be shuffled to some other partition. Okay, that's what is written here, right? So I hope you understood this. Now let's try to understand another important topic. So I hope the message key concept is clear to you. Now there is another important topic, that is producer acknowledgement. So what is that? The acknowledgement parameter which you can configure, I will show you the lab section in my upcoming video. Okay. So the acknowledgement parameter can control how many partition replicas must receive the record before the producer can consider the data is written successfully. Okay. So acknowledgement, from the name itself you can understand the producer is writing messages in our Kafka topic. Okay. That may be replicated in multiple partitions in different brokers for making the cluster fail safe. That is fine. So now the acknowledgement parameter makes sure that once producer is writing some data in our Kafka cluster, how many partition replicas should get that message, and then they will send back the acknowledgement to producer that the message is written successfully. That can be controlled by acknowledgement parameter. Okay. And this option has a significant impact on how likely the message to be lost. How it is that? Let us try to understand. Suppose you can configure acknowledgement parameter as 0. That time what will happen? That the producer will not at all wait for a reply from the broker before assuming the message is written successfully. Okay. So producer will just send the message. Due to network issue, if the message is not able to be written in the Kafka cluster, then producer will not at all think about that. It will just fire and forget. So that is basically very risky approach to keep acknowledgement as 0, right? So this means that if broker goes offline or an exception happens or the broker did not receive the message due to some reason, the producer will not know about that and the message will be lost. Okay. Producer will think, okay, the broker might have received the message and it is not getting any acknowledgement because we have kept acknowledgement as 0. So message might be lost in this case. Okay. And the picture you can simply understand like this way. The producer will simply publish the data to leader partition. Okay, it is written in append manner. Offset values keep on increasing. That's what is depicted here, right? The another acknowledgement can be acknowledgement equal to 1. So what that is saying, that the producer will receive a success response from the broker the moment leader receives the message. Okay, so suppose producer has published some message and the leader partition has received the message. Then what will happen? The leader partition will send an acknowledgement to producer that okay, the message is written. Then the producer will go ahead with some other activity or writing some other messages. Okay. If the messages cannot be written to the leader for some reason, if the leader get crashed or a new leader has to be elected yet something, then the producer receive an error response, and that a producer can understand that something went wrong. The message is not written properly in the leader, so it can retry sending the same message, avoiding the potential loss of data what we are facing in acknowledgement equal to 0. Okay, so here you can see the picture can be like this way, that producer here it is sending the data to the leader. Okay, suppose in this particular server our leader for partition 0 is present. Okay, once it is written in this leader partition, it will be sending the response or acknowledgement that okay, data is written successfully in the leader. Okay, so what is the problem here? The little bit problem can be that suppose you are enabling replication factor in this particular cluster for this topic, what will happen? The producer will not know that whether the message is properly replicated in other partitions which are present in other servers or not, because from them producer is not getting acknowledgement. Producer is not waiting to get acknowledgement from those in sync replicas. It is just waiting to get the acknowledgement from the leader partition, and once it get that, it starts other work. Okay, so that is one disadvantage in this acknowledgement equal to 1, that whether other replicas has properly replicated the message or not, that we cannot understand here. Okay, and the obviously last option remaining is acknowledgement equal to all. What that is indicating? That is saying that the producer will receive a success response from the broker only when, not only in our leader partition, but in all the in-sync replicas also the message is written properly. So the picture can be shown like this way, that here we are having our producer, it is sending the data to the leader is writing the data, along with that the leader will send the data to all the other brokers where the partition 0 same partition is present. Those are basically in-sync replica. They will be writing, they will be sending the acknowledgement to our leader. Then after accumulating the acknowledgement from all the in-sync replicas, the broker from the leader partition, the overall response will be going, and the producer will understand, okay, fine, everywhere the message is written and replicated properly, then it will go ahead with next message production. Okay, so that's the concept of acknowledgement equal to all. So obviously you can understand that in this particular approach there will be very less chance that the message will be lost. That is, if you want huge safety, then you can follow acknowledgement equal to all, but obviously with some advantage, some disadvantages will be coming. What is the disadvantage? The disadvantage is nothing but it's a slow process, because producer has to wait until the message is completely copied in all the in-sync replicas along with our leader and getting overall acknowledgement, right? So that's what is written here, that added latency but safety also is there in this approach, and leader and replica both acknowledgement required to the producer. Okay, so those are the concept of message acknowledgement. So I hope the concept of key and message acknowledgement from producer side is clear to you. These are the two important topics which you should be keeping in your mind when you are working from producer side. Okay, in my next video I'll be discussing some more concepts related to consumers and all. So if you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you.